You lived an entire life before you could remember any of it. You saw light for the first time. You heard voices. You learned to walk. You learned to talk. You felt things so big they made you cry without knowing why. And you remember none of it. Not a single moment. Most people think the answer is obvious. You were too young. Your brain wasn't ready. But that's not what happened. Your brain was recording everything. Something came and erased it. And here's the first strange thing. When that erasure stops, when your first memory begins, depends on where in the world you were born. Not by a little, by years. If you grew up in a Western country, your earliest memory probably starts around age 3.5. If you grew up among the Maori of New Zealand, whose culture places extraordinary weight on personal history and storytelling, your first memory likely reaches back to age 2.5. If you grew up in certain East Asian cultures, where childhood narratives focus less on the individual, your first memory might not start until age 4 or later. Same species, same brain, completely different starting point. Which means the question isn't just biological, it's personal, it's cultural, and it's stranger than most people expect. So what is actually going on? In 1905, Sigmund Freud was the first person to give this a name. He called it infantile amnesia. His explanation involved repression, dark feelings, uncomfortable truths the mind buries. Science moved past that a long time ago, but the name stuck. Infantile amnesia, the blank space at the beginning of every human life. The first thing that surprises people when they actually look into this, babies can form memories. In the 1980s, a psychologist named Carolyn Rovey Collier ran a beautifully simple experiment. She tied a ribbon from a baby's ankle to a mobile hanging above their crib. The babies figured it out immediately. Kick the leg, mobile moves. They absolutely loved it. When she brought the same babies back days later, they remembered. No ribbon yet. Didn't matter. They started kicking the moment they saw the mobile. 2-month-olds held the memory for days. 6-month-olds held it for weeks. So the infant brain can learn. It can store things. It can retrieve them. The memories were there. They just didn't survive into adulthood. Part of the reason is structural. Deep inside your brain sits a small curved structure called the hippocampus. It's the engine of memory. Every experience you can consciously recall, a birthday, a smell that takes you somewhere, a conversation you replay in your head, the hippocampus is what encoded it. But in infants, this system isn't ready. The connections between the hippocampus and the rest of the brain are still being built. A key gateway called the dentate gyrus isn't fully wired until somewhere between ages 2 and 4. So your infant brain could hold short-term memories, it just couldn't move them into long-term storage. Like writing in wet sand. It's there, then the tide comes in. But here's where it gets genuinely strange. In 2014, 2 neuroscientists in Toronto discovered something nobody expected. Sheena Jocelyn and Paul Franklin had a hypothesis that sounded almost absurd. What if the very process that builds your brain is also what destroys your memories? In the first years of life, your hippocampus is producing new neurons at an extraordinary rate. This is called neurogenesis. It's essential. Those new cells are wiring up the circuits you'll use for the rest of your life. But every time a new neuron integrates into an existing circuit, it disrupts the connections already there. The connections that were holding your memories. They tested this on mice. When they increased neurogenesis in adult mice, those mice started forgetting things they had previously learned. When they slowed neurogenesis in infant mice, those infant mice held on to memories longer than normal. The conclusion was deeply counterintuitive. Your baby brain wasn't too weak to hold memories. It was too busy growing. The flood of new neurons that built your brain also wiped the memories stored inside it. Your earliest experiences weren't lost because they were never saved. They were lost because your brain kept building new rooms and had no choice but to tear down the old walls. But there's one more piece, and it might be the strangest of all. To form what scientists call autobiographical memory, the kind where you are the main character replaying something that happened specifically to you, you need something most people never think about. You need a self. You need to understand that you exist as a person, that things are happening to you, that there is a you for them to happen to. Before roughly 18 to 24 months, infants don't have this. There's a classic test, a small dot of rouge on the nose, a mirror. Before 18 months, the baby reaches for the mirror, tries to touch the other baby. After 18 months, the baby reaches for their own nose. That's me. That moment, the birth of self-recognition, tracks almost exactly with the earliest age at which lasting personal memories can form. You can't remember being a baby, partly because there was no you yet. Not in the way you experience yourself now. There was no narrator inside your head turning experiences into a story that belonged to someone called you. Which brings us back to the cultures. Remember the Maori children whose memories reach back a full year earlier than average? It's not that their hippocampus is different, it's not a biological advantage. It's storytelling. The Maori oral tradition places extraordinary emphasis on personal narrative, on history, on the story of who you are and where you come from. Maori parents don't just talk to their children, they narrate them. They tell the child's own story back to them, in detail, from the beginning. And that narration, developmental psychologist Catherine Nelson spent years establishing this, is what gives memory a skeleton. Language doesn't just describe experiences, it structures them. Before you could speak, your experiences were encoded as raw sensation, sound, light, warmth, the feeling of being held. But without words to organize them, those impressions had nothing to grip onto, no shape, no framework. Once children begin speaking, and especially once adults start having conversations with them about things that already happened, their ability to form lasting memories changes dramatically. Remember when we went to the park? Remember the dog? That simple question is doing something profound. It's teaching the child how to build a memory that survives. In cultures where that narration happens early and often, memories reach further back. In cultures where it happens less, the blank space is longer. The culture you grew up in didn't just shape your values or your language, it shaped how far back into your own life you can see. Here is what actually happened to your earliest years. Your hippocampus wasn't ready. And even when it started to be, the flood of new neurons tore through the circuits that held your memories. You had no sense of self to anchor experiences to. You had no language to give those experiences a shape that could last. It wasn't one thing, it was everything, all at once. Every human being who has ever lived went through this. Every person you have ever met has a blank space where the first years of their life should be. And the answer to why isn't that your brain was too simple. It's that your brain was doing something far more important than remembering. It was becoming you. And that required, quite literally, tearing down the person who came before.